Hi all, let's start with our classes today. I think that we will discussing this tree maps, difference between comparable or versus comparator to do add or remove. And let's first do this add or remove. Maybe let's try to write a program like when we are writing an array list here. Suppose we are writing an array list here. We are using a function, the collection for this array list dot add, or we can also write dot remove, and then we are doing it. Now, in one of the questions, in one of the interviews, I was asked to use means what Monica told that day, to use this add this data structure without using this particular collections inside a list, means without using the methods inside a list. So let's try to write a program. Suppose if I'm making a method called, this will be passing your list string. I need to add, means I have defined my list in somewhere in this way. I need to add some elements here without using this dot add or dot remove or something. I need to add. So let's try to write a program. So let's check. List, the return type will be a list. Suppose you make it add element. You will pass this list, and we will also add. Suppose I'm passing this list. A list maybe to add the element. I'm doing alt, the same array list that I am passing, and maybe a string element, the element that I need to add. And I will return this list itself. Now to add an element, okay, we need an array. We cannot directly add in a list, doing it something in a bracket or something. We cannot do that. So instead of that, let me define an array string, and suppose my array, and I'm just converting this. I need to convert this list to array. I'm converting this list to array, and I have to define the size. Suppose, see, if first the size, if you see the initial size is 0 when I've done a new operator on something. When I need to add an element, say, suppose if I'm calling this functionality, this particular functionality called add element, al equal to add element, and then I am passing uh, this particular, again this same array list, and suppose I want to add a. I've used static, so I can directly call this particular method. You can see now it's 0. Now I need to increase the size of this particular list or an array by 1. So what I can do is I can directly write the size as new alt dot size plus 1. So you can see it was first 0, then I have added 1, and then the size, the array list, this array size has become 1. Why this is giving me an error? Do I need to cast? It's already a variable I've given. Okay, check this. See, I have converted this list to an array. That was my string, so I'm already converting it to this particular array. Now you can see this array has my size 1. It was 0 as the list size was 0, so I've increased it by 1. So let me add this particular element in the index called alt.size. Means now it was 0. Suppose it was 0 for me, then I'm going to add this particular element that I'm passing, add here. You can check, and then I need to pass this list, so I need to reconvert this array to my list, and for that we have this called alt equal to arrays, maybe as list. I'm giving this array here and let's check this program, and let me check if it works. See, it is adding a. You can see in this list, if I use this method add something, and if I'm using this called my array string alt to array, I'm converting this list, this particular list that I'm passing to array, and the size is increasing. Now you can see if I add a, another element, if I add, suppose say if I'm adding c. So what happens? Now the size of this AL is 1. Now the size is for this AL is 1. So I'm passing it here. So the new array, this particular size becomes 2. You can check this particular becomes 2. So my array, this particular my array contains already this element called A. Now one more size I have already increased, that 2. And in that particular, this, suppose when I'm passing C here, my array at index 0 already mean you have added a. Now again we are trying to add c, so I have increased the size, and from here you can see the size is already 1 because it contains a. So particular this, my array at index 1, it will store c. This c is being stored, and then I'm passing it again. So you can check You can check this. See, it is passing me the C. Now again, let me try to remove, sorry, let me try to remove an element. So let me write another program that will help to remove without using any method or something. So I can do it here. Suppose I'm writing here, giving it to remove element, the same array I'm passing, the same thing I'm doing, but from here I need to remove an element, so I'm doing it here as a -1. And I need to remove the element, so let me start a loop for, let me have a counter to int count equal to 0 for string s equal to, sorry, string s and my array if s, each element is, if s not equals to, I'm giving a negation here, you can check, and this particular element, so s, so suppose I'm doing means I do not have to do something here, this list or something. So let me do this. See, suppose I'm not converting this my array list. I'm making a array list whose size will be this, the size of this particular list -1, and then I'm passing this, and I'm storing the values. If this is not equals this, then I'm storing this as count, this counter equal to s. Let me increment this count, and then I'm converting it to list, and then I'm passing the list. So this is my remove element. If you can check the array, the list that I'm passing, I'm taking an array whose size will be this size often, because I am removing an element, so the size will be -1. Then I am I'm just transversing each element and checking a negation has been given. So if s is not equal to that element, then an array I'm storing the element. So if it becomes the element, it will neglect that particular element, and it will this element will be automatically removed, and then I am just casting it or just making this array to the list again, and then I am returning the list. So you can check. Suppose if I had given here two more elements, add element something d m. Now I want to remove the element. I'm going to remove this element called d. Now system.out. Let's check. See, this remove element is working. So first I have added this all the elements without using any dot add or dot remove. You can check, and then I'm removing these elements. Monica, Tejashwani, and I think Anusha, do you have any question regarding these two programs? I think Monica asked me this question that day.
Yes, sir. No, sir. No doubt.
No, sir.
Okay, you are fine with this, Monica? Means because
Yes,
you asked this specific this question. Did you ask this question itself that without using the add and remove we need to, or your question was something else?
this one only, sir. Like writing the code behind what was the,
Okay.
yeah.
Okay. Okay. So you can do this because they are going to ask you this particular two elements only because even I was asked in my interview, means when I joined the second company of my life to do this particular program to show them, and I did almost similar to this because it's 2 years back. I don't remember what I did, but I did this
Okay.
almost similar.
Okay, sir.
Okay. Okay. So let's go to the tree map functionality. Uh, let's go to tree map. We were at our HashMap demo, and you can check this particular when I was running this program. It was, see, it is not in the sequence that I have added, or it is not in the ordered set. Neither it is in the ordered set, nor it is in the sequence. You can check here. So to make it a sequence or in ordered set, we have it called your tree map. So instead of this, if I had given here tree map, let's check tree map and tree map, and let's check what would happen. Why it is giving me something. Okay, now check. Now if you are checking the tree map, you can see something. Your means it has been in the sorted this particular these things has been sorted and it has been printed in Zane, John Doe, Smith, Todd Hall, and Tom Smith. So you can check it has been sorted when I have used tree map instead of the particular hash map. So hash map, you remember this, it is not going to be ordered or sorted, but remember tree map, whenever you are using a tree map instead of this hash map, so it will be your sorted, means the keys will be sorted and will be printed, means it will be sorted inside your this map, and when you will print this, you will get a sorted map inside the memory of JB, inside the memory of the computer. Now you have an question, means you can, so how this in background, how this sorting takes place in the tree map or in your particular called hash map. So there are two methods actually that can be done. uh, Two interfaces, you can say two interfaces for this sorting. The interfaces are for sorting. Let me remove this. For sorting, you have two interfaces. One is called comparable interface, and another interface is comparator. Suppose you can say comparable um, it is used to means suppose it is used when until and unless I write a program, it's very difficult to make you understand because it will be a theoretical part and it will be difficult for you to cope up if I don't write a program. So let me first explain a bit, then I will directly go to the program and then we will come back. You can see that comparable, it is used to impose natural ordering. That means like if you are ordering it in 1 2 3, means sorting it 1 2 3, then it is a natural this or something called a comma b comma c. This is a natural ordering, you can say. And but in comparator you can say that this this imposes ordering on some collection objects like array list object or your list map object or something. This can be done using the comparator. So remember, in collections we use mostly this comparator and we do it like this called collections dot short, and then we do this. Suppose if I had given it here, I had given it here after removing an element. Let's check collections dot short. Suppose if I was giving this, you can check. And if I'm not removing this particular element, first not removing, and then I'm doing a print al. Was it a sorted one? Easy. Yes, it was a already sorted one. But let me do a change here. Suppose if I had added D and M at first, you check this now. See the difference. First, when I was printing, it was printing in me in M A D C. So system dot print out. When I was doing, it was printing me in the order that I have added. Now I'm doing a collections dot sort. You can check it is sorting me, and the printing is A C D M. So in your collections, you always use this particular interface. Inside it, it's the comparator. So you can do something called on some collection objects, but here you can do some natural ordering like 1 2 3, and this type of things can be done using comparable. This is one of the main thing that we are using. And remember, if I write this comparator, it uses a method that is your uh, int compare. This interface has a method, this particular method called int compare. And you can take int compare, you can take the objects like objects O. I told you the collection objects. So these are the collection objects like objects. Suppose it is object O1 and this is objects O2. 2. This is the comparator we have. It has the int compare. I'm comparing these two using this. And the thing is, if you have something called natural ordering or something incomparable, you just use this particular method called int compare to, and then you're passing an object. Suppose this object, okay, you can see the return type is int. So either it will give me an integer or a zero or a positive integer or a negative integer. So this particular compare, it gives me um, means if this object 1 is greater than your object 2, this particular object 2, then it will return me, sorry, it should be less. If it is, as it is a ascending order, so if the object 1 is less than, then it will return me a positive. Or if it is equal, then suppose if it is equal, O1 equals O2, then it is going to give me 0. And if O1 is greater than O2, it will give me your negative integer. But int compared to, which returns a negative integer, means this will give me a negative integer or 0 or positive. If this object, suppose you have something inside your array list or inside your something called country name, your array list has some string. So object 1 string at index is the previous index, maybe it is 0, is less than this string at index 1. If it is less than 1, then it will give me a positive. Similar, if it is equals, then it will give me 0. If it is greater, then it will give me a negative integer. This is the most this particular difference. This is the object 0, means only one object is passing, so it is imposing your natural ordering, and it is taking two objects. Suppose list, you have two lists and it is comparing between the two lists. It is doing within the one list, it is comparing within the one list, and it is returning in this way. And remember, it is defined this particular package. These are two different packages. So let's do a program first. Let's do a program. Then you can understand the difference between comparable and compare. Let's do a program called your class is equal to country. And this country implements my comparable. Country itself, and I am adding this unimplemented method. See, when I have done this particular called comparable, okay, this particular method has come to int compare to. You can check. I had written this particular called int compare to. It will take the object of only one object. That is, it is taking your called country argument 1. So let's rewrite this object. Before that, let me write the constructor, And before writing the constructor, I should give int country ID and string the country name. Inside this constructor, I need to give country ID, comma, string, country name. Let me write a super. This dot country ID equal to country ID. This dot country name equal to country name. This constructor I have written, and if I want to get a setup method also, like public int get country ID and return me the country ID. This let me write generate this greater status source. So this has been, instead of writing in hand, I have written particular to get country or the get country name and the set or everything. So let's do this. You can check this functionality. Instead of writing in hand, I have done a get or something. And now you check this particular thing what I'm doing. If I'm returning, suppose this particular country ID, the present country ID that I am passing here, if it is less than the country ID that I'm passing here, country dot country ID, then I'm asking it, then I am saying it to return me -1, else something called this dot. If it is greater than your country dot country ID, then it should return me your 1 or 0 if it is equals. So this is I have done. You can give it something called, if it is less, as it is something called 1, it's better to give it in this way. If it is greater, then it is -1. And let's do it and let's check it. Remember, I'm passing it. See, I have giving it a by default. Means this I'm overriding, and you can give -1, 1 as you like it. Whether you want to give it less than 1 or greater than 1, it depends upon you. So let me write a comparable main. This class called comparable. This will be my main class. It has your main functionality. Now I'm adding this country, suppose India, I'm making an object with India. Now I'm giving new country. Suppose I'm passing it as 1 and then I'm giving it as India. Suppose country USA, the object is this. Then again country, I have the ID called, then I'm giving it 2, then it is as USA. Suppose let me give me something called country. You can say Russia equal to new country 3, comma Russia. Suppose country Japan. If I'm giving Japan, new country 4, comma Japan. See, the objects I've created, I could given any object name, so but I've given India to India, USA to Russia, and Japan to Japan. Now I'm going to create an array list. Suppose I'm creating an array list. It will have this particular country. This generic will contain me this particular list of this country, and then the array list will be list of countries equal to new array list, and it will be your country. I'm importing this. I made an array list and I'm adding all these particular lists. List dot add. First I'm adding India. Suppose let me not make it order. Suppose I'm making it 1, 2, 3, and this as 2. I was making it ordering, then it will be USA, Russia, add Japan. This. So before, let me print out before sorting. Let me print this out. List of countries. Let me check how this is going. Okay, this is giving you the object's name because I have given country, not string, so it is giving me the object's name. So let's print the country names. For country, country. Because this is the type return, the generic is my country. So let me do this. This out. Country ID. Let's check. country dot get ID and also the country name plus plus country name. It's country dot get country name if I'm doing. Now I'm printing it. Let's check what it gets printed before the sorting. See, before the sorting, it's printing me the way I have. It is not in the ordered. You can check. I've given say 1 4 3 2. I need to sort this according to this. Before sorting, this is the country ID and everything that is being printed. Now I am calling this called collections.sort. Collections.sort, and then I'm doing it your list of countries. See, in your list of countries, I have just overridden. I've written something called comparable. So it is not taking my comparator which I have told before. Since this country, I've implemented this comparable, and now you are checking. See, now you are checking with this, and let me print it after this particular sorting. After sorting, let's check. Let's check. See, it's printing me 1, 2, 3, 4. It is calling me the comparable method and it is taking the country name. Suppose if I had given here 1 and -1 here, and let's check how it's going to print me. See, it is printing me in the descending order if I'm changing this particular country. So you can check. Int in my comparable I had called compare to, in this particular called compare to this particular object, and I'm passing only the object of this particular country and checking. Suppose this means this particular instance when it is coming as your suppose when I'm doing a collections dot sort, first it is checking with this what it is, this particular called 1, then it is checking with your 4, then 3, then 2, then it is just passing, then again your 4 3 2, then it is passing again, then 3 2, whenever you are just using this called compare to. Now you can check, and remember this comparable, it is defined under the package called java.lang, and this particular it defined, this comparator is defined in your called java.util. See, it's java.util. Now if we go with the comparator, suppose the same thing what happened here, I written a country now with a country called comparator, using this particular called comparator. Suppose this, let us make a country again. Let me rename this or leave it. Let's do a comparator now. Country comparator. Oh, I've written country. Let me rename this. Let me provide int country ID, same thing, and the string as country name. Okay, let me get the constructor public country ID and string country name. This I'm copying this getter setter again, and let me write a comparator class, maybe short by comparator. Here I am implementing this particular called implements comparator, and this is also my country. So it is defined inside my java.util, and this is defined inside my java.lang, this comparable. Now I'm doing a unimplemented C. It has two objects, like you can say object I've given here when I was giving the example object O1 and object O2 and this country 2. Now I'm going to return this return. Remember this thing, what I have given, if it is a positive, it can be changed. I was doing in the descending order. This is in the descending order. So if I just change, if it is less than a negative equals 0, and if it is a positive number, then it will be an ascending order. We have already checked. Now I'm just returning this particular value. Check here. I'm just returning this return country one dot get country ID is less than your two country two dot get country ID. If it is less, then I'm passing it as -1. Else, if I'm passing, if it is greater, if it is greater, sorry, if it is greater, then I'm passing it as 1. Else, if they are equals, then I'm passing it as 0. You check the difference here. I have passed through this. Now let me do here only. I'm doing it as I'm not going anywhere. The same thing, compare main. So maybe I'm writing here is the list of objects. Before the sorting, I'm writing it here. Now, now let me write a comparator main. It will be good instead of using that. I'm copying this comparable main from here. Inside my comparator, this is going to be country comparator, sorry. This was my country form per, oh, I've written this way. Now comparator main. Where is my comparable? Yeah, comparable main. I'm going to do this till here. In my comparator main, I'm going to write the same, but my this will be, I'm creating an object. You can check. This was my country comparator. For sorting this, now let me do a collections dot sort. Suppose I'm doing a collections dot sort collections. First, let me do this. New. What I had written? Short. Suppose if I had given new this. Let's check what happens. See, it is sorting me 1, 2, 3, 4 when I'm giving it. So you can check the difference between the comparator and the comparable. This, if you do a program, please, your assignment is do a program on this particular called sorting comparator and comparable. Do you have any questions regarding this comparator and comparable? Anusa, Monica, and Tejshwani?
No, sir.
Okay, your assignment, next assignment is going to be that write a program which will differentiate this is comparable versus comparator. This is, you can write directly collections dot sort, you can write directly, but you need to know, like comparator, it has an method called compare. It will take two objects like compare object 1 and object 2, and that it means it validates accordingly, and then it does the work. And when it is comparable, when I'm doing a comparable, like inside my country it is there, if it is a comparable, see, I'm taking only one object and then I'm doing with the particular current object with the one that is I'm passing. So you have, if you have any questions, and your assignment with this also, this will be when to use comparable. Please Google it and tell me, and when you will use comparator. I've already given a hint that it is used to impose natural ordering like 1 2 3 or ABC. It takes the current object, and then with the current object in your comparable, it takes the current object and then it is sorting. But it's taking two from here. It is taking both the objects that we are passing and then it is sorting. So this is the hint that it do the natural ordering, and it does on some collection objects. So when you will use this comparable and when to use comparator, and do an example to better understanding between the difference between the compare and comparator. So we have finished with the collections. Now next class we will go with called files. Next class will be my files.
Okay, sir.
And I think, yeah, I think that will be the last class, means not the last class, the last says last, what I will tell, the files will be the last chapter that we will be covering in core Java, and then we can move to the advanced Java part.
Okay, sir.
And yeah, core Java, something you need to know it very carefully, because in your interviews and everything, uh, your interviewer is going to ask you the details level or your concepts in core Java, and only the basic concepts they ask about the your, whether it's Spring, struts, or your JSP servlet. They are going to ask you only the basic stuffs there, because the everything lies in your particular called core Java. Anyways,
Okay, sir.
for
Yeah.
today, yeah, let's bye, and we will meet the next class with the files. Bye.
Yes, sir. Thank you.
Bye.